Right now, your body is producing a drug. It's completely natural. It's been there since you were born. And in the right circumstances, it's more powerful than morphine. You've heard of it. You've felt it. But almost nobody knows what it actually is, how it works, or what it's quietly doing to your brain at this exact moment. It's called endorphins, and the science behind them is stranger than you think. Most people think endorphins are some kind of feel-good chemical your body releases when you exercise. That's true, but it's also almost completely wrong. Endorphins are neuropeptides, small proteins that act as chemical messengers in your brain and nervous system. The name itself tells you everything. Endorphin is short for endogenous morphine, morphine that your body makes itself. There are over 20 different types of endorphins. The most powerful is called Beta-endorphin. When researchers compare its pain-relieving potency to morphine in controlled conditions, beta-endorphin is between 18 and 33 times stronger. Let that land for a moment. Your body produces something 18 to 33 times stronger than morphine. On demand. For free. Endorphins work by binding to opioid receptors in your brain, the exact same receptors that morphine, heroin, and oxycodone bind to. This is not a coincidence. Opioid drugs were specifically designed to mimic endorphins. They work because your brain already has a built-in system for receiving them. When endorphins bind to these receptors, two things happen simultaneously. Pain signals get blocked before they reach conscious awareness, and your brain's reward system activates, releasing dopamine and creating a feeling of euphoria. This is why a soldier can take a bullet in combat and not feel it until hours later. This is why athletes can finish races on broken bones. The endorphin system doesn't just reduce pain. Under extreme enough circumstances, it eliminates it entirely. Here's what the feel-good messaging around endorphins never tells you. Because endorphins bind to the same receptors as opioid drugs, your brain manages them using the same mechanisms it uses to manage addiction. Repeated activation of the endorphin system through extreme exercise, certain foods, even laughter, causes your brain to gradually down-regulate its opioid receptors. It reduces their sensitivity to compensate for repeated stimulation. The practical consequence, over time, you need more of the same stimulus to feel the same effect. The runner who needs to run further every week to feel normal. The person who can't feel pleasure from ordinary activities anymore. Your brain's natural painkiller system operates on the same addiction logic as heroin. Not metaphorically, literally the same receptors, the same compensatory mechanisms, the same tolerance curve. This matters for you specifically because endorphin release is happening constantly in response to things you do every day. Eating spicy food triggers endorphin release. Capsaicin activates pain receptors, which trigger the endorphin response. This is why spicy food is addictive, literally addictive, by the same mechanism as opioids. Laughter triggers one of the strongest endorphin releases measurable in a laboratory setting. A 2011 Oxford study found that social laughter elevated pain thresholds by up to 10%, purely through endorphin release. Even eye contact and physical touch with people you trust triggers endorphin release. Your brain is constantly medicating itself through your social interactions. Remove those interactions and the medication stops. This is part of the biological mechanism behind loneliness causing physical pain. It's not metaphorical. Loneliness reduces endorphin activity and your pain threshold measurably drops. Here's what science still can't fully answer. We know endorphins exist. We know they bind to opioid receptors. We know they're extraordinarily powerful. What we don't fully understand is why the system exists at all in its current form. Why does a biological organism need an internal painkiller 33 times stronger than morphine? What evolutionary pressure created something that powerful? The leading theory is battlefield triage, that extreme endorphin release evolved specifically to allow injured animals to keep functioning long enough to escape predators. Your body essentially has a built-in emergency override that can shut off pain entirely when survival demands it. But that doesn't explain the social bonding component or the laughter component or why spicy food triggers the same system as a traumatic injury. The endorphin system is older than our species, and we still don't fully understand what it's for.